It's on a Sunday. Let me show you something else that will have you speaking in tongues. Wait till you encounter this type of power supplies. In the input, we have the EMI filters, common mode inductor, and a class X capacitor for EMI suppression. Maybe include an NTC to protect against inrush and a varistor for high voltage spikes. This voltage is rectified, and on the other stage you get the active power factor correction, power factor inductor with its switching transistor. And this transistor is controlled by some circuitry that boosts this voltage. After that, now we move to the switching stage. And because this is a high power supply, you find they are using more complicated topologies, like an half bridge or a 2-switch forward, or any other topology that uses more than one transistor to drive the transformer. Oh yes, and those two transistors have their own control circuitry to drive them. This is the transformer and the secondary winding. And on the next stage, you'll have rectification and output filtering. Now, instead of using a normal Schottky diode, you'll find they are using a synchronous rectifier, which is a transistor. And this transistor is driven again by another circuitry. Then you have a choke and the output capacitor. We are still not yet done because this is for the high power. We need another small power supply for standby. Now this has a simpler design that we are used to. But you also need a control circuitry to drive this transistor. And then on the output, we just have a small diode and the filter cap. Good luck trying to diagnose this kind of layout with all these control circuitries. They could be in one package or they could be connected with some form of feedback. What keeps men awake and sweating at night?